So moving on, more stuff about quadratics. I want to start out with what's the zeros of a function. And essentially we're looking for what are the x-intercepts. What are where the graph crosses the x-axis. So it's x values that make y equals 0. Or they're the x-intercepts. In other words, we're looking for the x values that would fit in a point like this here. Because you agree, the height, this here has to be 0 if it crosses the x-axis there. So what are the x values that would give you a height of 0? Fair enough? Okay, so quadratics, we have 3 possible situations that we could have. So I'm going to start by just drawing in a graph. Actually, I might as well quick do a graph for all 3 of those. If you want to just do a coordinate plane, an xy graph for each one. And we're going to have one of 3 scenarios. So my first one is kind of what I tend to picture most often. So you could have a parabola, they could open up or they could open down, right? Quadratics could open up or open down. I'm just going to have one that opens up, so something like this. Maybe try to make it look kind of symmetrical as best I can, quickly doing freehand. So one possibility is that we're going to have that point right there and another point over here somewhere. So if yours don't cross in the exact same spots, that's fine. But, so for this, one possibility is that we're going to have 2 zeros. So 2 zeros. Or if you wanted to, you could say intercepts. Maybe I should have said x-intercepts. So 2 zeros or 2 x-intercepts. And in that case, I'd have like this one here is maybe like a -1. And if that's a -1, this one maybe looks like it'd be a 5. So you could put down numbers that look a little better for yours. I'll change them both into points. But here you could have something like that. So -1 and 5 would be 2 things that are the zeros. For this next one, I could have 2 zeros, so it could have 2 x-intercepts, or I could have 1. Should we make this one open up or down? What's your preference?
Down.
I have a couple people down, so I'm going to just pick someplace on my x-axis and have it open downward. So you want it to just kind of touch. So that point that in this case would be the highest point is on the x-axis. You guys remember the name of that highest point?
Vertex.
Vertex, nice. So this one here has 1, 0, or x-intercept. And, maybe that would be like, I don't know, a -2-ish. So -2 then would be a 0. Or if you wanted to, you can make it a point and say -2, 0. And the last possibility is we could have no zeros or no x-intercepts. We doing a parabola, a quadratic that opens up or down? Up. Okay. Well, we could do one of each if we wanted to, really. But if it opens up, then you just have to start above the x-axis. Your vertex has to be above. So something like that would give you 0 zeros. Or if you were to have one that opens down, it just have to be entirely below. So either one of those would have no zeros. Good for that? So when we're finding these zeros, sometimes you'll have one answer, sometimes you'll have no answer, sometimes you'll have 2 answers. Is it possible to have 3?
No.
Nope. Not possible to have 3. All right, so now if I were to draw these correctly, so I actually copied some in because my drawings often leave something to be desired. But if this is my vertex, if I were to take and try to do a vertical line through that, if I could fold the paper on that vertical line, the right side here should lay right on top of the left side, if I did everything correctly. So they call that line the line of, or the axis of symmetry. So it's a vertical line that divides a parabola into 2 symmetrical halves, 2 halves that look the same. You could do the same thing over here for one that opens down. You could have your vertical line and it would work. Now, for vertical lines, are those the ones whose equations are x equals some number or y equals some number? Are all the x's the same on a vertical line or are all the y's the same? So if I were to, so I'm getting mixed results, I wouldn't mess up your notes with this, but let's say this point right here is 4, 0. This point right here, do we know the x is 4 or do we know the y is 0? x is 4. So it's 4 and some other height, maybe, I don't know, a 7. But so if we have a vertical line, it has to be x equals some number. Fair enough? Okay, so if we're going to try to find that axis of symmetry, and I'd ignore all that brown stuff, we know it's going to be x equals something. There's 3 ways to get it. First way, I'm just going to write in here x equals a number. And I'm going to put a little arrow to the number and say it's the x value of the vertex. So if you know what the vertex of the parabola is, if you know what the lowest point for this one is, that's the vertex, the highest point here. If you know that point, you just grab the x value, x equals that number. Work for you? So in this case here, the x value is a 4. If this really is 4, 0, my x value is 4, so it would just be x equals 4 would be the equation for this vertical line. Fair? Enough? If we don't know that, though, we could go up here, and let me pick this one. You could do this to your notes if you wanted to. You could skip it. But if I'm trying to find this vertex, and leaves a little bit desired because my drawing isn't perfect, but what's this x value? How is that going to relate to my -1 and my 5? Did you agree that x value for the vertex is right in the middle? So what do I do to -1 and 5? What math thing to find the number right in the middle?
Subtract.
Not subtract. It's going to be 2. Oh, I'm sorry. Go ahead.
The mean?
Yeah, the mean or the average. So if you average your 2 x-intercepts, if you are in this situation where you have 2 x-intercepts, it won't work here. But you just average those 2 numbers, you get the mean or the average. So the other thing would be x equals the average of the x-intercepts. In some cases, it'll be super easy. Just, look at the vertex. Do this first way. Sometimes you'll know the 2 x-intercepts, so average them. It's easy to do the second way. Sometimes you have to go to this third way, which the third way, if you're given, this equation hopefully looks familiar. We did that yesterday and said any parabola could be written in this equation. Fair enough? And if we're looking for the vertex, that x value, x equals, we said we had to have which number? A, B, or C? A. There has to be an A value. So maybe that'll help you remember the denominator. It's a fraction, and the bottom is 2A. So we said A couldn't be 0, because you agree 2 times 0 is 0, and then we'd end up with dividing by 0, and that doesn't ever work. So that's going to be one part of it. The other thing is the numerator is a -b. So in other words, if I had, I don't know if I'd write this in, but say we have a 3x squared plus 12x minus 9. If you wanted to find the vertex, well, you could just, I'm going to write it over on the side so I don't mess up my big, beautiful equation. This equation is important, so make sure you learn that equation. Scroll down a little bit. Yeah, this equation, it comes up a lot. You'll know that thing and love it by the end of the chapter, maybe. Okay, so -b would just be -12, right? Because b is this positive 12 right there. If it was a -12, then we'd have to do negative of -12. All over 2a, which is 2 times 3. So -12 over 6 then gives us just a -2. So if we had that parabola, or that quadratic given by that equation, the equation for the axis of symmetry would be x equals -2. Is that fair? Okay. And then, so finding the vertex. Steps. Find the x value. So average the x-intercepts, or x equals -b over 2a. I got a little ahead of myself. But now if you're trying to, okay, sorry, I hit the ground running. So we're trying to find the vertex. You guys good on vertex? Vertex, we're saying if we have a parabola, maybe something like this, we're looking for this point. Do you agree? We just went through 3 ways to find the x value of that point. So that was the step number 1. Find the x value. So you could average the x-intercepts. You could do this equation. Our first way was look at the x value of the vertex. So we're assuming if you're finding the vertex, you don't know that one. Okay, so we have that. Once we know that x value, do you think I could take my x value and put it in the equation to find the y value? So put in the equation and find y, and then write as x comma y. So if we were to do that thing here. So find the vertex of this. Well, we're trying to find our point x comma y. What's our easiest way to find the x value? Since we know an equation, it's probably to use x equals negative b over 2a. So now for this one, what goes in my numerator? What does it end up being? Perfect. It's a positive 12 because it's negative, but then my b value is a negative 12. And you agree negative of negative 12 is just positive 12? All over 2 times a, and a is 3. So then my x value ends up being, 2. So it's 12 divided by 6, which is 2. So I'm halfway there. The x value of my vertex is a 2. And now once I'm done with that, I could just take my original equation and put a 2 in there for x, and put a 2 in there for x. So I get a 3 times 2 squared minus 12 times 2 plus 4. Sometimes it's honestly easiest just to take that and pop it in your calculator. If you want to do it in parts, just make sure you do order of operations correctly. So 2 squared is 4, 3 times 4 is 12. Then you have minus 12 times 2 is 24. So that gets you to a negative 12 plus 4 should get you a negative 8. So in theory, if we punch it into our calculator, we should get this negative 8. So we know then this parabola has a vertex at 2, negative 8. Make sense? One last comment before I turn you loose. There's a question in the book, or some questions in the book that do things like, will this fit? Could you get something that's this high through an arched doorway? Could you get a sailboat like this here? Will this sailboat fit underneath the bridge? What we're really looking for is the highest point of the bridge right there is going to be the vertex. Agreed? If you're trying to figure out kind of the height of the vertex above the water, are you looking at the x value or the y value? Yep. So find the y value of the vertex. If the y value ends up being, maybe like a 9, and the sailboat is a 10-meter high sailboat, then it's not going to fit. The sailboat's too high. If it's only an 8-meter high sailboat, then it'll fit underneath it. Good? So that one's in the